What is up, Algebra 2 students? This is Lesson 10, and our objective for today is what is and how do you use the Pythagorean theorem? Now, if you've made it this far and have never heard of the Pythagorean theorem, you've been living in a box. So just a quick review of what the Pythagorean theorem is. Pretty much it says that if you take three squares, that the sides are a right triangle, the areas of the two smaller squares will add up to the area of this big square. So think about this red box down here. Each side length would be a and a, so the area of that would be a squared. This blue box over here on the right, the side length of this would be b and b, so the area of that would be b squared. And this big black box, the side length would be c and c, so the area of that would be c squared. So pretty much the Pythagorean theorem says that a squared plus b squared is equal to c squared. And the cool thing about this word being a theorem is that it actually does have a mathematical proof. It's not just something you can take, or you can just take it someone's word, but you don't have to. There's actually a proof behind it that this can be proven to be true. We're not going to go to that today because, well, you probably don't want to, and it'll take too long. So we're just going to go ahead and start using the Pythagorean theorem. Alright, so this is not one of them from your book, it's one I just made up. It says, use the Pythagorean theorem to find side R. So notice this beautiful picture over here that some artist drew for you. Man, is he good. We're looking for the side length over here, R. The side length is 6, the side length is 10, and the side length is R. The main thing I guess you have to remember when you're talking about the Pythagorean theorem is that you have three side lengths, a squared plus b squared is equal to c squared. The main thing you have to remember is that c is always the longest side. Generally, we tend to write the a with the shortest, which puts b with the middlest length. But a and b doesn't necessarily matter. The main thing there is that you have c being the longest side. So in this case that we have right up here, RC is going to be R. So then what we're going to do is we're going to say 6 squared plus 10 squared is going to equal to R squared. Well, 6 squared is 36. 10 squared is 100, so it's going to equal to r squared, which is going to be 136. It's going to be r squared. Well, we're not looking for r squared length, we're looking for the length of r. So the opposite operation of squaring something is to take the square root, just like the opposite operation of multiplying something is to divide, or the opposite operation of adding something is to subtract. The opposite operation of squaring something is to take its square root. So that means the square root of r squared is just going to give me r, and that's going to be the square root of 136. We'll talk about how to simplify down square roots at a later time, but for now, that will be awesome. So the length r is the square root of 136. That's your exact answer. If you throw that in the calculator, you will approximate that to be 11.661938, blah, 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 blah. Okay, and that number goes on for forever without repeating or without terminating or stopping. Alright, this is actually practice A from your book. It's there on page 59, not 59, page 62, if you want to look at that. But it pretty much just says this: use the Pythagorean theorem to find side A. Now don't be confused about my 9 and my A. This one up here is 9, and this one down here is A. So don't be confused. So our longest side is going to be 9. So my shortest side is going to be 5. So 5 squared plus A squared is going to equal to 9 squared. 5 squared is 25. A squared is, well, we don't know that, so we'll just say a squared. And 9 squared is 9 times 9, which is 81. We're trying to get that a by itself, so I'm going to subtract 25 from both sides. Now we'll get a squared is equal to 56. So to find A, we're going to need to take the square root of both sides. It's going to give me A is equal to the square root of 56, which is approximately equal to 7.483314773547, etc., etc., etc. Alright, so that's the basic idea on how to do that. One more, we're going to do practice B, which is here. It says use the Pythagorean theorem to find the distance between these 2 points. So to find the distance between these 2 points, let's just go ahead and graph them. 5, 3 is right here, where the x is 5 and the y is 3. And -2, -3 is down here, where the x is -2 and the y is -3. So we have this point and this point. What we're going to do is we are going to use the coordinate plane to create a right triangle. And our counting skills to count, this is 1, 2, 3, 4, 5, 6 in length. This one is 1, 2, 3, 4, 5, 6, 7 in length. And we're looking for this distance here. So what we're going to do is we're going to say, since D is the longest side, that's going to be the C. So I'm going to say 6 squared plus 7 squared is equal to D squared. Well, 6 squared is 36. 7 squared is 49. D squared is D squared. So 49 plus 36, 55. 85 is equal to D squared. Take the square root of both sides, and D is equal to the square root of 85, which is approximately equal to 9.219, so I'll say 9.22, and that will be our answer. Your homework for today is actually going to be a worksheet, so sorry you can't start on that early. You have to just pick it up in class. I hope you don't mind too much. Good luck. Feel free to watch this over and over and over again until you cannot stand my voice anymore, or until you understand, whichever one comes first. I hope it's the latter. Good luck, guys.